earlier when we told our class. I don't know, Mr. Edgar one day sat class was doing that back and forth.
That's what I do.
What's another one? Some more.
Well, I got to start now, so I can't keep going, but I've got lots. So yeah, let's do this. Let's get this done. We can kind of put a bow on this whole unit here by getting this done. So today is May 17th. And this does get capitalized because it is a proper noun. It is not, sometimes people misspeak and call it, hey, are we using the quadratic equation? No, it is called the quadratic formula. Capitalized because, again, it is a proper noun. It is a formula that we use to solve things called quadratic equations. And so, again, it is not, we never talk about it as the quadratic equation. It is a tool used to solve quadratic equations, okay? So let's get that out of the way first. And where it comes from is something that I probably won't show you. No, I will not show you this year. I will not show you how to derive this formula. It's not the right time for that because we'd have to learn completing the square, which I don't think we'll do. But anyways, it does come from a really neat place. It's not something that someone just like invented. It's just a natural discovery. It's quite brilliant, actually. But anyhow, the quadratic formula is used for solving quadratic equations like this. And the idea here would be, you know, I could mess with you and start class by saying, okay, we're going to warm up today. I don't want to toy with you. So, but I could say we're warming up. I want you to solve this, just like on the quiz yesterday. Come on, this is easy, go. And what happens after about 15, 20 seconds is people start looking at you weird. And the realization is that you literally cannot. And you know so much about factoring. You guys are so good at factoring. It wouldn't even probably take you 20 seconds to realize that this ain't happening. Like you can build your cute little shells and you can put in X's and then you realize, gosh, if I'm going to multiply to make 4, my options are 1, 4, 4, 1, 2, 2. And none of that is ever going to give me the 10. So what I wanted to leave you with is for this year, I don't want you to leave thinking that, well, I can't solve this equation. That's not good practice to say that. We can solve this equation and we can solve any equation. We just have to have a different attack method. And that attack method is, well, the quadratic formula. And I'm going to write it down and then we're going to make sense of it, talk about the letters, because you're going to see some new letters today that you've actually been seeing all along. We just haven't generally addressed them as such. Anyways, here it is. You're going to want to write this down and you're going to want to write it neatly. And you're going to want to probably write it relatively large. And you're also going to probably want to write some colored boxes around it and maybe draw some arrows and stars and stuff. You're going to be using this a lot. Okay, so what the quadratic formula says is in an equation like this, provided that it's set equal to 0, x will always be equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I can't possibly explain why this sticks. There's a little song that goes with it. And I tell you, I was a little bit taken by surprise and flattered last year when Lane Burnett made her valedictorian speech. She mentioned of all the things that she learned in high school, one of the only ones that she stuck was my stupid quadratic formula song. And I think Ryan Fogg is going to mention the quadratic formula song again this year. I can't possibly figure out why people enjoy it so much, but it does have a nice little kind of a little happy ring to it. It's sung to the tune of the Jack in the Box song, you know, the dun 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 dun. You know what I'm talking about? And it's the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Just like that. And for some reason, it sticks. And I didn't used to teach the quadratic formula song for probably the first 18, 20 years of my career. And then I suddenly realized, wow, things like this, I guess, help. I never would have thunk it. But anyways, it's just that little Jack in the Box kind of pop goes the weasel tune. And it really will help you, I think, to kind of feel the flow of the formula and how it works. The only issue I have with the song is that it starts out with the quadratic formula's negative B. And a word that I sometimes use in place of negative is opposite. And I think that that will help you if you want to make a little comment in your notes. We will often read this out loud as negative B, but I want to make sure you understand that that's the opposite of B. And it's not like you wouldn't understand that. I just want to make sure we're clear that if B turns out to be 4, then into the formula there, we would, of course, put negative 4. But what if B is negative 4 already? Then we put it in as a positive 4 because it's the negative of a negative or the opposite of a negative. Okay? So I'm not going to require you to sing the song. I never, ever would do that. I would never put you in a position that I would be uncomfortable in myself. I just want you to know that it's out there, and some of you will get it stuck in your head and some of you will not. And but that's kind of how, that's a little device you can use to help yourself remember the flow, because this is going to be something that's going to be pretty near and dear to the next few days of your life, this formula. So the big question, of course, is, okay, Mr. Ahern, thanks for that really weird looking formula. What the heck is A, B, and C? Do you know who they are? You've been seeing them. You just never at any point have I had a reason to tell you who they are.
X squared is A, the 10x is B.
Yes. Good, Kinsley. The A, the B, and the C are what we call the coefficients of the polynomial. And so we haven't talked about those words in a long time, but the coefficients are the numbers in front of the terms. So in this particular quadratic equation, A is 1. It's invisible. You can't see it, but it's obviously there's a 1 in front of the x squared. I hope you agree. What's B? Just 10. The x's will never, well, not for many, many years, x will not be a part of your A, B, and C. A, B, and C are just the numerical coefficients of the terms. No x is allowed. Having said that, what's C? Good. I write these down. I cannot recommend strongly enough that you do the same. Don't just watch your math teacher write it down. If you haven't figured this out about me by May 17th, the way I produce notes on my TV is I write down what I would expect that you would write down and how you would write it down. So actually taking A, B, and C and plucking them out of your quadratic equation and giving them a space on your paper goes a long ways. Okay? Now, let's practice. And so what we're going to do here is we're going to figure out what the solutions of this quadratic equation are by plugging A, B, and C into the quadratic formula. So for the first of many, many times to come, here we go. So we're going to start by writing variable equals, in our case, since we're solving for x. Not all problems will have x. If the quadratic equation that I provide for you is like n squared, then you would write n equals. But since we're working with x's, we're going to write x equals. And here we go. The first thing you encounter in the quadratic formula is the opposite of b. What would that be? So we're going to put negative 10, and then we put plus or minus. And we'll talk about what that plus or minus thing is all about. Not right now, but we will. The next thing that you encounter in the quadratic formula, once you get inside that big, long, behemoth square root sign, is b squared. And that's 100. Don't ever write the b value with a squared on it. Always do this step right while you're thinking of it. And the reason for that is because what happens if b is a negative and you square it? It still becomes a positive. And what happens is as b starts to get bigger, people type into their calculator like negative 17 squared and it says negative 289. Those people don't know how to use calculators. They forgot parentheses or I don't know what they're doing. So always do b squared right here on the spot and write it down. So like in our case, 10 squared is obviously 100. And I teach I've been teaching a long time, and I change things every year. I always will be. But one thing I've never changed is how I feel about this next step. I believe in this strongly. The next thing you should do is copy down the -4, and then don't put numbers in place of A and C. Not yet. I call it -4 blank blank. I'm still not going to put them in now, because I like to give this step a little bit of time to just sit and simmer on the stove, and I'll come back in a minute. And then I'm going to go to the bottom, and this is more math that I would encourage you to do while you're here on the spot. What is 2 times A? 2 times 1 is 2. Good. Now I go back and I retrofill the A and the C slots inside the square root sign. So what will go in place of A? In place of C? Very good. So that's the initial way this is going to look. That's not, I haven't done much math. I mean, quite frankly, we did 10 squared and we did 2 times 1. Ooh, you know. And now it's time to do the math. And the math at this point will always exist inside of the square root sign. So the math that is now our priority is there. And this isn't hard. This is, let's talk about the numbers at the end. What is 4 times 1? 4 times 4, 16. So what the square root really says inside of it is 100 minus 16. You don't want to be the kid that breaks the order of operations and does 100 minus 4 first. Don't be that kid. That ship should have sailed with the 4th grade, right? We don't do that. We multiply all the stuff and then we subtract when we're done. And what's 100 minus 16? 84. So here's our current answer, and it cleans up quite nicely. -10 plus or minus the square root of 84 all over 2. You still with me? Those answers are weird. I say answers, you're like, I only see one answer. There's actually 2. Their names are -10 plus root 84 over 2 and -10 minus root 84 over 2. We just conjoin them into this one nice little package. Now, there's one big bridge that we have yet to cross, and that is, here comes something from your past. You don't have to answer this yes to be polite, but do you remember those? Remember a quiz we took called Roots and Powers? Do you remember the first row of the quiz? I put square roots up there and you had to make your little tree and simplify them. Does that ring any bells? So I need your help. I need to break down or simplify the square root of 84. Could you help me? You know what's going to come in super handy? Remember that little factoring sheet that you used on your quiz yesterday with every number from 1 to 100 and all the ways to multiply to make it? You know what I'm talking about? That is going to be a huge helper. I'm saying you keep that thing. And if you need it, I'll show you the website where I got it from. You can print as many as you want. Do you know the numbers that we're looking for that multiply to make 84? Something that can be square rooted. There's 2 and 42, trash. 3 and 28, trash. There's like 6 and 14, trash. 7 and 12, trash. 4 and 21, not trash. So off to the side here, I got a little side project. I need to take the square root of 84 and break it up into the square root of 4 times the square root of 21. Which becomes what? Nice. Now what I'm going to do is I'm going to re-inject this back into my quadratic formula answer. And it's now going to say x equals -10 plus or minus 2 root 21 all over 2. Have I managed to just completely lose you yet? Yes? Hanging on. You actually have to simplify within what you can call like the Bermuda Triangle. I don't care what name you give what I'm about to show you, but take a look up at the board. You can't miss it. I'm going to draw a triangle, and I want you to draw the exact same triangle. This is a really important triangle. Well, geez, how coincidental that Doritos have 3 sides, just like triangles. That's nuts. Absolutely nuts. I never figured. So, it's not a triangle. Darn. Gosh. I guess I'm done for the day. So the reason I want you to draw that triangle is because when Kinsley asked the question of can't we reduce the this and the this, the answer is, well, yes, but you're only allowed if all numbers inside the triangle, you can call it the Dorito of awesomeness. If all numbers inside your Dorito can be divided by the same number, then you may reduce them all simultaneously. Can they all be divided by anything? 2. So what happens now is we wind up with this as a final answer. X equals -5 plus or minus the square root of 21. Done. Yes, and if I'm any good at this job and you're any good at your job as math students, the next 3 or 4 minutes is going to be really critical and it's going to go really, really well for us. I want this now to be something that makes sense to you. So I need you to grab a calculator or your Chromebook, either one, or you could just watch me work, but I think you'll benefit from this if you're part of the process. The first thing we're going to do is with some sort of electronic calculating device, we're going to have our calculator. By the way, what's going on right now is just me caring about you and wanting you to understand these answers. You won't do this on every problem. I want you, though, to go, oh, that makes sense. You should say something like that in about 5 minutes when we're done. So any scientific calculator that does square roots is fine. Now, at this point, I need you to understand something with me, that this in the white box is the final answer. You put that on a test, you're getting 100%. However, I need you to understand that it's really 2 different answers. One of them is -5 plus the square root of 21. The other one is -5. Good. Now I need a translation. I like my brain and your brain. We like decimals. We like someone just to say, for God's sake, what do you mean, like 7.2? Yes, that makes sense to us. And so using our calculators, we're all going to type in -5 plus the square root of 21. We're going to hit enter. And assuming you know how to use a calculator, you're going to figure out that that answer is approximately -0.417. Everybody get that? That number makes a hell of a lot more sense than -5 plus the square root of 21. That's something I can get my head around. Now, let's head to the other one and let's do the same command, only let's change it to minus. So we're going to do -5 minus the square root of 21, hit enter, and I'm going to get x is approximately, notice I've switched to the squiggly equal sign here. These are not perfect decimals. This one is -9.583. Is everybody at peace with this so far? Now, going back a while, a week or so, we played on a program, a website called Desmos. Do you remember Desmos? If you want to, at some point, you can get Desmos on your phone. It's a free app. It's a perfect app. And its interface is just like the website. They made sure that the things are laid out and like visually the same from app to website, whatever. Anyways, let's go to Desmos. You don't have to if you want to watch me do it. Like, I don't want to put you out or anything here. So if you just want to watch me do it, I don't care. I need to... And here we are. Again, what I'm doing right now, these minutes are intended only to flip a light switch on so that you understand the meaning of -5 plus or minus root 21. On its own, it's just a trash number. It's just this weird thing. So we're going to go into the Desmos box and we're going to type in y equals. Actually, you don't even have to type y equals. That's a bad habit. You don't have to. You can just do x squared. Remember, that was our problem. What came after x squared? Plus 10x plus 4. Good. Now, the mission here, what I'm trying to get your head around is this idea that these numbers, they're not just things like it wasn't like some long bearded guy in a cave 1,000 years ago. This stuff really all comes together. When we just typed our answers into our calculator, the first one, do you remember what the decimal was when we did -5 plus root 21?
Negative 0.417.
Negative 0.417. If you go right there, if you zoom in on Desmos and you click on that dot where the graph crosses the x-axis, there is our negative 0.417. I need you to understand that -5 plus or minus root 21 isn't just a thing. It's two numbers that are in what we call exact form. And you know exactly where this is headed. What was the other decimal we got when we did -5 minus root 21? So you can zoom out, scroll across, and you know exactly where I'm going with this. Click on that one, and boom, there it is. I need you to understand that those are not just weird symbolic things that we write down. -5 plus or minus root 21 means number over here, number over here. We just tend to not express them as decimals. We tend to express them as -5 plus or minus root 21. Yes, what a smart thing to say. It's a great way to check your work, Shariah. Excellent way to check your work, yes. Let's do another quadratic formula problem. And feel free to use Desmos liberally, in whatever fashion you think is responsible. So the next one I'd like you to do is x squared minus 18 equals 4x. Yeah, absolutely. We got to fix this thing. Nice job, you guys. Good job. The quadratic formula will only have any functionality if you've got your quadratic equation in standard form set equal to 0. And now that we have it in standard form, what's A?
1.
What's B?
-4.
-4. What's C?
-8.
Nice. Be real tight with those negatives. And there's going to be some funky stuff that's about to happen, okay? So we're going to get a little bit outside of our comfort zone here with what we're about to do with the quadratic formula. So here it goes. X equals, what's the first thing I write? +4. That's the opposite of an already -4. And then we put our plus or minus sign, and then we put this awkwardly long square root sign. Generally, if you think your square root sign's long enough, you probably need another H on it. You got just a bunch of junk you got to put in there. So we got to first do b squared. You don't need a calculator for this. 16. Question, will that part right there where I'm pointing with an arrow, will that always be a positive number? Yes, it will, because it's b squared. You square a positive, you get a positive. You square a negative, you get a positive. I mean, you're going to get a positive. Did I? Yeah, right. Did I? Yes. So, and then I'm going to do this the same way I always do. I'm going to put -4 blank blank. And then I'm going to jump downstairs and I'm going to put my basic math. 2 times A is 2 times 1 is 2. Go back and retro fill your A and your C. Who goes in place of A?
1.
Who goes in place of C? Now, there's a really important moment here. I've exceeded the amount of time that scientists say you're allowed to keep talking to kids and expect them to listen. So I hope you hear this. There's a negative. Yes, and this really matters. Let me point to this little fellow. You see this little guy? Nope, not an exponent. This negative that I'm pointing at with a red arrow and this negative that I'm pointing at with a green arrow, they have no choice but to eventually find each other. And what happens when 2 negatives find each other? They become a plus, a positive. And so really what's happening now is inside of that square root sign, I no longer have any subtraction. I have 16 plus 72. Holy Toledo. And obviously I just did 4 times 18, right? 4 times 1 is 4, 4 times 18 is 72. But the idea there, the big upshot of that 30 seconds is,
what about the
let's work this out. I don't want this to be somewhere where we get stuck. So let's work out that funny looking white shape there. Let's work it out. What's -4 times 1? -4. What is -4 times -18? +72. You okay with that?
Oh, so
you just multiply. And now I will do 16 plus 72, which is 88. Good.
Oh.
So I wind up with x equals 4 plus or minus the square root of 88 all over 2. And again, I implore you, think about the radical, the square root, and always ask yourself, am I at peace with the root of 88? Yeah, you shouldn't be. You should think 22 times 4, 4 times 22. And feel free, again, to use that sheet until the numbers get too big, and then it's between you and your calculator. But 88's on the sheet, 4 times 22. So if I go off to the side and I break it into root 4 and root 22, because that's the best I'm going to do, I'm going to get 2 root 22. So there's always like this little side, this detour. You go off to the side, you screw around with the radical for like 10 seconds, and then you bring it back in. So in place of the square root of 88, I'm going to bring back in his acceptable and simplified version to root 22. And it's time to draw your Dorito. Can they all in the Dorito be divided by anything?
Yeah.
2. So what happens is when you divide things and they become ones, there are times in math, you learn this from me or from someone else, there are times in math where ones aren't necessary, and there are times when they are. And both of the ones, just like on the last problem that we're going to create, we don't need them. So why superfluous? I love, what a brilliant word to use. Yes. So we wind up with x equals 2 plus or minus the square root of 22. And I mean, just use your brain. 22 is pretty close to 25, right? We can agree. So would we also then agree that the square root of 22 is just a little bit under 5? And so if let's just say it was close to 5, and you added 2 plus 5. What's 2 plus 5? So you would expect your parabola to come up and cross through your x-axis a little bit before 7. Right? Sure. Nice. Exactly. Nice. And if we were to go to Desmos and graph it, we would see the parabola going slice, slice. And those spots of slicing would be right at the decimal equivalents of those weird answers. Did you have a question? Okay. Let's go again. Do you want us to wait for you? I want you to be a part of this. Nice. So let's use the quadratic formula on this bad boy. What's A? What's B? What's C? Right. Write those down. I hope you trust me enough by May 17th to know if I tell you to do something, it's because I want you to do well, right? Writing those down will help you. Now we're going to go and plug them into our happy little quadratic formula. Would anyone like to try to sing the song? You forgot already. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a.
If you don't know the song, you can come it out.
It's a pretty good song. So let's do this. X equals, what goes first? Plus or minus, unnecessarily, well, long square root sign. You can if you just want for some odd reason to be different, but generally that's not what we do. I don't want to have weird conversations with you about how you want to express yourself. Generally, mathematicians say plus or minus. Like cupboard, if you want to pronounce it cupboard and you want to go through your life like that, you're welcome to. But, and then what's going to go on the bottom? No. 8.
Oh, yeah.
All over 2a. If a is 4, your bottom is 2 times him. 2 times 4 is 8. Got it? The bottom of the formula says to multiply a by 2. A we can clearly see is 4. Double that. That's what goes on the bottom. Coy, you good?
Yeah.
Now I'm going to go back and retrofill the a and c values inside the radical. A is 4 and negative 5. And
Negative 20, and then it's multiplied by negative 4, so it'd be positive.
yeah, if you just want to make your life a little bit easier, you can take this to the bank. First off, we're never going to let a, not right now, we're not going to let a be negative, are we? We control our situations and we always make a positive. So this number right here with the red arrow is never going to be negative. All I simply have to remember is this, follow the green arrow. If this number is negative, then overall, the problem inside the square root sign just becomes a big dumb plus sign. That's it. So we got to do some math here. What is 4 times 4? 16 times 5 is 80, and 64 plus 80 is 144. So we wind up now at an interesting crossroads. X equals negative 8 plus or minus the square root of 144 divided by 8. And if this lesson, there's always like, as teachers, we draw things up and we get moments and we say, God, I hope this happens. And I'm at a moment right now where I hope someone says something. That is important. You know, this is the part where we're used to going off to the side and we're used to going off and saying, well, how can I break up the square root of 144? Hey, newsflash. What is the square root of 144?
Wow.
Yes. So what I'm going to do, why are you yelling at me?
I thought those 8s just become 1s too.
Don't go there yet. So we're going to go outside, take the square root of 144, and go, oop, you equal 12. We're going to bring that back in, and we're going to replace the square root of 144 with 12. And this is one time, I hope you're still listening. I've got more examples, but I might feel like we got to probably almost be done. This is one time when you don't use the triangle. I had a whale of a time. We start algebra 2 with a little bit on quadratics. They had a hard time with this. Are you listening to me? Don't do the triangle. Do the math. These are what we call rational solutions, and it means I can just do the 4th grade math. Follow what I mean here. No triangle necessary. No triangle necessary. I need you to understand that on the top, there are 2 things. You ever read like a choose your own adventure book? One of those where you can,
Oh, yeah.
you can choose your own adventure. You can take the plus path or you can take the minus path. Let's take the plus path and watch what happens. What is negative 8 plus 12?
4.
Positive 4. Negative 8 plus 12 is 4. Put 4 over 8. One of your answers is 1/2. Now let's trace the other pathway. So we go back in our choose your own adventure book and we say, well, what would happen if I pick the minus path? Well, let's pick it. What's negative 8 minus 12? And what's negative 20 over 8 reduced to? Negative 5/2. Now, I got about 3 minutes or 4 minutes left that I get to spend with you. I'd like to point something out. Does anyone want to take a guess as to what these answers mean? Could someone read back the original problem to me? Are you ready? You ready? I'm going to factor this. And I wasn't about to tell you at the beginning of this problem, hey, surprise, we can factor this. But I want you to have a moment right now where you realize, son of a gun. So if my answers come out like this, without the root thingamabobber and all the plus and the minus, if they come out these nice answers like this, that means, ah, snap, I could have factored this thing. And the factors, of course, are, and you're welcome to check my math. And this would be just like a question that I would have put on your quiz yesterday. And in hindsight, now you look at it and you go, huh, of course, that's easy. So the connection there is like, so wait a second. So I could have solved this one by factoring, but I also, yes, solve it however you want. But the quadratic formula is our bailout. It always works. But this proves that, hey, sometimes you could have factored also. You see the answers, right? How obvious this is? What answer do you get out of here?
-5/2.
Jackpot. And from here?
+1/2.
Done. Easy peasy, right? I'm going to stop recording because I'm starting to cough. And I'm going to hand out assignment number 81. It is not homework, but I'm just going to get it out of my possession and into yours.
81.